In this video, we're going to continue our discussion with inference about two means independent samples. So let's take a look at the confidence interval regarding the difference of two independent means. So a simple random sample of size n is taken from a population with an unknown population mean and an unknown population standard deviation. Also, a second simple random sample of size n is taken from a second population with an unknown population mean and an unknown population standard deviation. If the two populations are normally distributed or the sample sizes are significantly large, a confidence interval about mean 1 minus mean 2 is given by the lower and upper bounds given below. Okay, so let's take a look at an example with this. So construct a 95% confidence interval about the difference between the population mean weight of a state quarter versus the population weight of a traditional quarter. So what do we have at this state? We have two independent populations with a mean. It's asking for a confidence interval, and we're asking about the difference of two means. Now, keep in mind, I've already written out the requirements for this in a previous example, and they're exact same requirements as the hypothesis testing in this section. All right, so now let's put this into the calculator. So, how do we do this? It's stat, highlight, test, and for me, scroll down to 0. That's going to be the two sample t interval. Hit enter. So for us, it's data. So list 1 is L1, then L2. Both frequencies are 1. Confidence interval is 0.95. Pooled is always no. Highlight, calculate, hit enter. And remember, I will always round this to 3 decimal places. All right, so let's put this on the paper now. So on the paper, it should be two sample t interval, right parentheses L1, comma L2, comma 1, comma 1, comma, whatever the confidence percentage as a decimal, comma no for the pooled part. And written below, I have the confidence interval rounded correctly to 3 decimal places. So let's interpret the results. So I'm going to write that down now. So we are 95% confident the mean difference between the mean weight of state quarters and traditional quarters is between 0.010 grams and 0.96 grams inclusive. So if it's just asking about the interpretation and it's not testing, then this would be okay. But I'm going to write another question below, and I'm going to try to answer that slightly differently. What does the interval say about the mean weight of the quarters? Now remember, I'm going to write this in parentheses just to kind of give you an idea of the thought process behind this. Okay. And again, here's the question. Is 0 in the interval? Well, let's take a look at the interval. Clearly 0 is not in the interval. So what can the confidence interval tell me about the mean weight of the quarters? Let me write that out now. Since the confidence interval doesn't contain 0, there seems to be sufficient evidence to suggest or conclude that there is a difference in weight between state and traditional quarters. So one other thing, a quick note here. We would use the pooled two sample t-test when the two samples come from populations that have the same variance. Pooling refers to finding a weighted average of the two sample variances from the independent samples. It is very difficult to verify that two population variances might be equal based on sample data. So we will always use Welch's T when comparing two means. That's why we will always say no for pooled in this section.